Morning everyone. Whether the board is visible? Okay. So tell me the subgroup. What kind of subgroup we have to test? Okay, Rahul, that's great. Tell me the elements of subgroup. Zero two. Next. 0, 2, 3 and 0, 1. 0, 1, 2, 4, 5. Okay. So tell me how many of you had solved these examples? Rahul. Anyone else rather than Rahul? What about others? No problem. Sequence doesn't matter. What about others? Kanaya, have you tried it? You have to perform the mod 6 operation only on the given sets. Okay. So start with 0, 2. So this is 0, 0, 2. Okay. Then again 0, 2. And you have to perform mod 6 operation only. Okay, okay, Kanaya, no problem. Okay, so 0 plus 0, 0, mod 6, 0, 0 plus 2, 2, mod 6, 2, again 2, 0, 2, mod 6, remainder 2, and 2, 2 is 4. Okay, and 4 mod 6 gives us remainder as a 4. Now we have to check that whether the given subgroup is group or not. Okay, so for the group, as we know that first we have to check the closure property. And what is closure property? Whatever answers are present in the table must be present in the set. But as we consider here, it gives us 0, 2, 2, 4. Now 0 and 2 is present in the set, but 4 is not present. So this subgroup is not satisfy the closure property, and if it is not satisfy the closure property, then no need to check for the further one. Okay, that's why this is not a subgroup. Right? Then we will moving towards 0, 2, 3. Similarly, we have to find out the remainder 6. Right? So again, this is 0, 2, 3. Again, 2 plus 0, 2, 3 plus 0, 3. Okay, 2 plus 2, 4. Again, 2 plus 3, 5. 5 more 6 gives us 5. Then P03, 3 plus 2, 5, 5 more 6, 5, and 3, 3 is 9. So 9 more 6 gives us remainder as a 3. Right? Again, what happened here? Again, 4 and 5 is not present in the sets. That's why this is not a subgroup. Okay? Then we have to move in towards 0, 1, 2, 4, 5. Okay? 0, 1, 2, 4, 5. So first row become as it is because 0 plus anything gives us that element itself. Similarly, here 1, 2, 0, 1, 2, 4, 5, 4 and 5. Okay. After that, 1 plus 1, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 1, 6. 6 mod 6 gives us remainder as a 0. Then again 2 plus 1, 3, 2 plus 2, 4, 4, 6, remainder 0, 7, remainder 1. Again 4 plus 1, 5, 6, remainder 0, 4, 4, 8. 8 mod 6 gives us 2 and 9 gives us 3. Then 5 plus 1, 6, so remainder is 0, 5 plus 2, 7, remainder is 1, 9, that is remainder is 3, and 10, remainder is 2. Again, what happened here? In this set, the element 3 is not present, that's why this is not a subgroup, because it does not satisfy the closure property. Okay? Have you understood it? How to check closure property? Write down in chat box. What about others? Have you find it difficult for solving the examples? Rather than Rahul and Kanhaiya, what about others? At least write down in chat box yes or no. Okay, Priyanka. What about others? These are the normal mathematical functions we are going to perform. And based on this, just we have to check the properties. Shall I moving towards next? Okay. Now, there is one theorem, that is Lagrange theorem, and based on this, we can find out the size of the set which might be subgroup of the given group. Okay. So, write down the definition first. Write down the theorem. Write down theorem. For any finite group, for any finite group, say G, the order of subgroup H, the order of subgroup H of group G, of group G, divide the order of G, divides the order of group G. The order of group represents order of group represent the number of elements. Number of elements. Okay. So what is Lagrange theorem? For any finite group, say G, the order of subgroup H of group G divides the order of group G. And what is meant by order? It represents the number of elements present in set G. Okay. For example, in our previous example, there are 6 members. That is 0, 1, 2, 3, 4 and 5. Right? And suppose my sample H group having 2 elements, 1 and 2. Now, as per this statement, we have to divide the number of elements of H by the number of elements present in the G. Okay, so there are 1, 2, 3, 4, 5, 6 elements, and we have to find out the divider of 6. So the divider of 6 are 1, 2, 3 and 6, right? 1 is also the divider of 6, 1 and 6 itself. Okay, so the H, that is subgroup, contains either 1 element, 2 element, 3 element or 6 element. For example, 41, we know that the identity set is the subgroup of G. Okay, then for 6 means that group itself and either 2 or 3. Okay, so as we are considering in our previous example, whenever we are putting the 5 elements in the subgroup H, it does not satisfy the closure property, right? So with the help of this theorem, you can decide how many numbers should be present in the subgroup H. Okay, got it? Just we have to find out the divider of the number of elements present in the set G, and with the help of this theorem, we can find out how many numbers should be available in the subgroup H. Okay. Now, there is one question which is occurred in GATE exam 2014. So, I am going to dictate the example, or I am going to write down it on board, and you have to tell me the answer. Okay. This question occurred in the GATE 2014 examination, which is based on the Lagrange theorem. So write down question. Let capital G be a group. Let capital G be a group with 15 elements. With 15 elements. L be a subgroup of G. L be a subgroup of G. It is known that L naught equals G. L naught equals G, and the size of L is at least 4. Is at least 4. Then find out the size of L. Find out the size of L. Okay? So try to solve it using Lagrange theorem. So just I am going to give you one hint over here. The size of G 15 is given. Okay. So recall the definition of Lagrange theorem and try to find out the size of L. Also, you have to check the conditions which are given in the question. What is the condition? L is not equals to G. I'll give you 3 minutes. It's 10:34 now. You have to solve it till 10:37. In short, in this example, we have to find out the size of subgroup L. So how to find out the size of L? For that, first we have to find out the divisor of 15. The size of G is 15. So Rahul, tell me whether the 4 is the divisor of 15. Okay, then what is next? Constraint. The size of L is at least 4. At least 4. And what is another constraint? L is not equals to G. Five is the right answer, Priyanka. Very good. Okay, it's 10:37. Okay. So first, as we know that G be a group with 15 elements, means the cardinality of G is 15. So first we have to find out the divisor of 15. So divisor of 15 are 1, 3, 5 and 15 itself. Right? After that, what is next constraint? L is not equals to G. That is, L is not equals to 15. So we does not consider the 15 over here, right? After that, we have a choices 1, 3, 5. Then what is our next constraint? L is at least 4. Means at least 4 or more than 4, right? So 1 and 3 we are not considering because these are less than the 4. That's why 5 is the right answer. Okay? Okay. Then we'll moving towards our next topic, that is coset. So first write down the definition of cosets. Let capital H be a subgroup. Let capital H be a subgroup of capital G whose composition have been denoted multiplicatively let small a belongs to capital G, then h of a is equals to HA, where h is belongs to set H. This is called as a right coset, and AH is equals to A into H. Again, H is belongs to capital H. This is called as the left coset. So first write down the definitions, then we'll moving towards the example. Now suppose G is equals to 1 minus 1, I and minus I, and H is equals to 1 and minus 1. Okay, so just we have to follow the properties of the coset. So what is in the cosets? Let capital H be a subgroup of G whose composition have been denoted multiplicatively. So what is meant by composition? In composition we have to perform the multiplication operation. Okay, so there are two types of coset, right coset and left coset. So small a is belongs to set G and capital small h is belongs to set H. Okay, so how to find out HA? Here this is right side, that's why it is right coset, and this is left. So in right we have to take H from the set capital H and A from the set G. Okay, and in AH we have to just perform the vice versa operation. We have to consider the element from G and then we have to consider the element from H. So write down this statement first. Remember that we have to perform the multiplication operation here. Okay. So first we are going to find out the right coset and then we are moving towards the left. Okay. So first we have to consider HA. So H, that is H is belongs to set H. So I am going to write down here like this. HA is equals to, suppose we have to consider the H from the set capital H and then we have to perform the A. Okay. Suppose H dot A is equals to 1. We have to perform the operation for this. Okay. So this is equals to H is also 1 and A is also 1. So this is 1 into 1, 1. Okay. And what is another element? That is minus 1. So 1 into minus 1 gives us minus 1. So this is set 1 minus 1. Okay, got it? What I am trying to do here? First I am going to consider the element of set H, that is 1, and then set of A. Okay, so we are going to perform the operation with integer number and then we are going to moving towards the real number. Okay, so 1 into 1 gives us 1 and 1 into minus 1 gives us minus 1. Okay. Similarly, the next element present in H is minus 1. So now we have to perform the operation with H is minus 1 with 1. Okay. So again minus 1 into 1 is minus 1 and minus 1 into minus 1 gives us plus 1. Okay, similarly we have to perform the operation on I and minus I. So again HA, that is H into I. So for this I into 1 uses I and minus I into 1 uses minus I. Okay. Then again HA is equals to H into minus I. So again minus I into minus 1 gives us minus I and minus 1 into minus I gives us plus I. Okay. Similarly, now you have to perform the operation AH on the given set. What we have to do only, instead of AH, we have to write down 1 dot H. And similarly, 1 into 1 gives us 1. Again, 1 into minus 1 gives us minus 1. Okay, this is with this one. Again, minus 1 into 1 is minus 1 and minus 1 into minus 1 is plus 1. Okay. Then for I into 1 is I and I into minus 1 is minus I. Again, minus I into 1 is minus I and minus I into minus 1 gives us plus I. So this is HA set and this is AH set. Now, for this scenario, the values of left coset and right cosets are same, right? So when the values of left coset and right coset are same, then it is called as a normal subgroup. First write down the values of left coset and right coset. Just I am perform the multiplication operation here. Done. Okay. So this is multiplicative coset. Similarly, we can find out the additive coset as well. So first write down the definition. If let H be a subgroup of G whose composition have been denoted additively. So in this case, the set H is not given in the form of element. It is given in the form of function. Okay. So first we have to find out the element of set H. So try to find out the element of set H with operation plus. So make sure 3 into Z means what? Okay. So Z, okay, so instead of G, write down here, or instead of Z, write down here. Find out the value of set H. 0 is also present there, Krisha. So tell me this values of subset H with the help of 3Z comma plus operation. Right. So we have to perform only 3 into whatever element are present in the set G. Okay. So H is equals to first 3 into 0, 0, 3 into 1, 3, 3 into 2, 6, and 3 into 3, 9. So this is subset of G, that is H. Now try to find out the values of right coset. Okay, this is operation which is performed on the set H, and this is used to find out the set H. Okay, so what we have to do, we have to find out right coset, that is H plus A. Okay, so H plus A. Suppose the element of A means the element of G, that is 0. Then it becomes H. H is the element first one, suppose 0. So it gives us 0 plus 0, that is 0. Then H plus next element is suppose, okay. So we have to perform all possible operations with 0 with the help of set H. That is, I am going to write down the Okay. So we have to perform the addition operation here. So h plus 0, for h plus 0 result will be, we have to add 0 into the entire element of set G. So the set becomes 0 plus 0, 0, 0 plus 1, 1, 2 and 3. Right? This is for h plus 0. Similarly, we can find out for h plus 3, because 1 is not available in the, sorry, h plus 1, h plus 2, h plus 3. So h plus 1. So again 1 plus 0, 0, 3, 4, 7 and 10. Okay. Similarly, we can perform the same operation for h plus 2, h plus 3 as well. Okay. Same way we can find out the values for left coset. So this is homework for you. You have to find out the values of left coset and check whether the values of left coset and right cosets are same. Okay. That's it for the today. Write down your roll numbers in chat box quickly. 1 to 10. 11 to 20. 21 to 30. 31 to 40. 41 to 50. 51 to 60. 61 to 70. 70 onwards. Okay, students. Thank you for joining the session. Have a good day ahead. You may leave now.